Let's now talk about even and odd functions. Even and odd functions are special types of functions. An even function, f, yields the same output for both x and its opposite. So if you put in 2 and you put in -2, the same output will arise. Now what's that mean? Graphically, if you have an input yielding a y, then its opposite value would be exactly the same distance on the other side, but it would yield the same y value, so the same height. Now, if you do this for every x value, you would get a mirror image across the y-axis. So there is y-axis symmetry. An odd function says that for opposite inputs, you get opposite outputs. So if you put -2 in and you get +3, then when you put 2 in, you will get -3. So here we have a graph of an odd function. So if we put in x and we get y, when we put in -x, we get -y. This yields to something called origin symmetry. So origin symmetry can be easily seen whenever we fold across the x and then fold across the y, or fold across the y and then the x. So one axis and then the other. So if we fold across the x-axis, this point would end up down here, and then we fold along the y-axis, it goes over here. So how do we determine if a function is even, odd, or neither? Well, we put in -x into the function. Determining if we have an even function or an odd function comes down to playing around with negatives. So everywhere we saw x, we will put -x. So we're going to square -x. Notice the parentheses are important. We will cube -x minus 3 times -x. So now, the square of -x is x squared plus 1 over, now to cube a negative, we get a negative. So you'll notice now the numerator is exactly the same as the original function, but the denominator is the opposite. Instead of x cubed minus 3x, we have -x cubed plus 3x. Let's factor out a negative from the denominator. Now, that negative in the denominator can come in front. But now, what we have is negative, and then this part of our expression is nothing more than the original function. So notice what we've written. F of -x equals negative f of x. That means, go back to your definition, f of -x equals negative f of x. That means f is an odd function. Now let's look at another example. Again, we will substitute in -x for x. So we have the cube root of 9 square of -x minus 5. So this simplifies to the cube root of 9x squared minus 5, which is our original function, h of x. So we've just shown that h of -x equals h of x. Since h of -x equals h of x, that means h is even. What about g of x? G of -x equals 1 minus the absolute value of negative x. That's all going to be over the square of negative x plus 3 times negative x plus 5. That becomes 1 minus the absolute value of negative x is just the absolute value of x. The square of negative x is x squared minus 3x plus 5. Now the numerator is our original numerator. The denominator is almost the same except for the middle term. So factoring out a negative from the denominator isn't going to change this to make it the denominator of the original. So there is no way to play around with a negative and get some semblance of our original function. Therefore, g is neither even nor odd. So if we are given a graph and we want to determine whether or not we have an even function or an odd function, it comes down to looking at the symmetry. So first thing first, if we fold along the y-axis, do these match up? So if we fold here, does what we see on one side match up with what we see on the other? And yes. So since we have symmetry about the y-axis, that means that we have an even function. Now clearly here, we don't have symmetry about the y-axis. What we see on the right doesn't mirror on the left. Well, what about if we fold along the x-axis and then the y-axis? So let's just take a point that's really relatively easy to see. Let's say this point. 1, 3. If we fold down across the x-axis, we would have 1, negative 3. Then we should have, if we fold along the y-axis, negative 1, negative 3. But that point's not there. So if we fold and then fold, it does not match up. So this is neither. We have no y-axis symmetry, no origin symmetry, so this is neither even nor odd. What about this? If we fold along the y-axis, does what we see on one side match up with the other? The answer is yes. Again, we have an even function. What about this? If we fold along the y-axis, notice it doesn't match up. But if we fold along the x-axis and then the y-axis, what do you think? If we fold along the x-axis and then fold along the y-axis, we do have it matching up. So this does have origin symmetry. And since it has origin symmetry, it's odd.